Alrighty, Math 10C, so we are on to chapter 4. This is known as Roots and Powers. Okay, so chapter 4 is a very crucial unit. You're pretty much going to hear me say that about every unit, especially moving forward. Everything you're going to see is fundamental to the 20-1 and 20-2 courses. Okay, so if you can really knock these ones out of the park, you are going to feel way better in the coming grades. So that being said, let's get our fundamentals down. So for 4.1, we kind of want to know what is a radical. So after this video, you should understand a few things. The terms of a radical, okay, so that just means the definitions and the makeup of a radical. How to represent radicals using exponents, that's super important. And multiplying some bases and dividing similar bases. Okay, so this is kind of the first thing to knock out, terms of a radical. So first of all, what is a radical? A radical is something with the form this. So let's kind of just list a bunch of radicals to begin with. Okay, so radicals are where you have a square root and you have a number. So the square root of 4. Okay, we know what the square root of 4 is, that's 2. The square root of 2, we don't know exactly what the square root of 2 is, and we'll talk about that more later on. But this indeed is a radical because it has that square root symbol. What happens if we do that? Okay, these two things are not the same. This is known as cube rooting. Okay, so this, you would say the cube root of 2. Okay. That's how you would pronounce that. What happens if you had a 4 here? So the fourth root of, let's say, 8. This would be the fourth root of 8. That's how you would read that, the fourth root of 8. Okay, so as you can see, a radical is anytime you have this thing here, okay? And that is what we're all talking about here. So here, let's put some definitions to this. So this little value here is known as n. Now recognize when there isn't something there, okay, we all read this as square root. Okay, we all know what square root does. Okay, we know that this equals 2. Okay, but notice how we have to put numbers here. If there is no number there, you can imagine a 2 being there. So that simply means the square root of 4, that means the index is 2, okay? If you take the square root of 7, the index is 2, okay? And that only is for 2. So when nothing is there, you can imagine a 2 there. If the index is something else, that means you are doing a different type of root. If it's 3, it's a cube root, okay? So n is your index. It tells you what kind of root you're finding. The number inside is known as the radicand. So here, number 4 is the radicand, 2 is the radicand, 2 here is the radicand, and 8 is the radicand. And the radical, well, that's the whole thing. So this whole thing is known as the radical. Okay, so let's apply these definitions really quickly to example 1. So example 1 says, determine the index, radicand, and radical in the following expressions. So for A here, let's talk about that. Well, let's first find the index. So what I'm actually going to do is I'm going to make a little table to keep things organized. So let's make a little table here. So this will be the radicand, and this will be the radical. Okay, and this we will put cube root 4 here, and then section that off. There will be cube root, or fifth root -5, and then root 24. So first off, what is the index? So remember, the index is that little number that's right inside. So our index for this one is 3. Okay, what would be our index for the fifth root? Well, it would be a 5. So our 5 will be the index here. Okay, how about for our square root 24. Now remember, if nothing is there, you imagine a little 2 there. So that is the index of 2. Now let's talk about the radicand. So the radicand is the thing inside, okay? So what's inside of your cube root here? Well, it's 4, so that's your radicand. So So there's your radicand. Here, it would be -5. And then lastly, the square root, the radicand here would be 24. Now let's talk about that radical. So what is your radical? Your radical is going to be the cube root of 4. Okay, it's the whole thing. This would be the 5th root of -5. And this would, of course, would be the square root of 4. Okay, so there we've broken everything up and kind of used the definitions. Okay, so make sure you have the definitions down as it makes it learning this stuff a lot easier. Okay, so let's talk about something that's really important. The difference between an even index and an odd index. So remember, your index is that n value there. Okay, so what happens if n equals an even number? So 2, 4, 6, 8, 10. Okay, well, something really important happens here. So if n is an even number, and so on and so forth, so 2, 4, 6, 8, 10, there's a restriction on the inside here. Okay, the thing inside here, your radicand cannot be negative. Okay, so if you had square root, and remember, if nothing is there, you imagine a 2 being there. If you take square root -8, if you plug that in your calculator, this does not exist. You're going to get an error. So let's pull out a calculator quickly. So if I take square root, and remember, how do I get to the square root? I press second x squared to get the little square root there. And I'm going to put -8. Your calculator is going to give you an error. So calc error, that's non-real answer. So it's not a real answer. It doesn't actually exist. Now, what if I make it a 4th root? So I'll talk about this a little later, but let's do the 4th root of -100. Okay, well, it's not going to exist. So how do I do that? I'm going to press 4, and then I'm going to press math. And now what's going to happen is you are going to press this number 5 here, and it pretty much just has a little times there. So here it now has put that 4 into my index, and I put -100, and again, it doesn't exist. So anytime you have an even value for your index, this radicand has to be positive. It can be 0 as well, so just recognize that. The square root, anytime your index is anything, if it's 0, it just equals 0. That's an important thing to note. But just recognize, if your index is an even number, the thing inside has to be a positive number, or else it does not exist. Whereas over here, an odd index, it kind of changes a little bit, okay? So there is no restriction on the radicand. So an odd number would be like 1, 3, 5, 7, 9, 11, so on and so forth. So if we have n equaling that over here, your radicand can be any number. Okay, so like take for instance the cube root of -8. If you plug that into your calculator, you're actually going to get -2. And remember the relationship between these things, okay? This is talked about a little bit in our first units. And just recognize that -2 cubed equals -8. Okay, that's the relationship there. So the cube of -8 equals -2. Okay, so that's the relationship of your cubing and your cube rooting. Okay, hopefully you see those relationships. Now, if I take, let's say, let's go the cube root of, let's do -27, that's going to give me -3, because -3 cubed actually equals -27. And remember what that cubing means. To cube something, it tells me to multiply the number 3 times. Something you can see here is positive, or -3 times -3 gives me +9, and then my -3 follows down this -3 here, And that's why it's negative. 9 times negative 3 equals negative 27. So that's why if you have an odd index, you can actually have negative values inside, and the actual answer will be negative. Okay, so there is no, it can be any number. There's no restrictions on our radical, or our radicand. Okay, so let's just call it x here so you don't think it's a 0 going back to your notes. Okay, if it's an even number, there is a restriction. Okay, so let's maybe move on and do a few questions together. Okay, so let's kind of review. Remember, we've learned this. We learned this in, I believe, chapter 3 at the very beginning. And that's perfect square roots and cube roots using prime factorization. Okay, so how can we tell if something's a perfect square or a perfect cube? Well, we can prime factorize. So remember what prime factorizing is, you're breaking it down. So the first thing I'm going to do is prime factorize. So 196. So let's do 196 and divide that by 2. And that gives me 98. Let's divide 98 by 2 again. That gives me 49. And then 49 is divisible by 7. And that gives me 7. Okay? Now remember, if I want to tell if something's a perfect square, okay, a perfect square root, what can I do? Well, remember, this index is 2 here, and I need to group up my numbers into 2s. So here I have a group of 2, and then I have a group of 2 7s. So essentially, the square root of 196, well, that's going to equal 2 times 7. We take one of our numbers and plop it in there, and we take another one of our 7s here, and that will give us 14. So the square root of 196 actually equals 14. That's why it's a perfect square. Okay, and we were able to group numbers into 2s, perfect groupings. Okay, so again, that should be a review for you. So let's maybe see if this is a perfect cube. So you can see our index is 3 here. So I'm going to divide this by 2, and let's kind of see what happens. So 3, we learned how to do this. Oh, sorry. So 216 divided by 3. Actually, we divided by 2. My bad. So divide by 2. So 260 divided by 2 gives me 108. Let's divide that by 2. And that gives me 54. Let's divide that by 2. That gives me 27. And then 27 is divisible by 3. And that gives me 9. And then 3 turns into 9 and 9. Okay. Now here, we're trying to see if this thing is a perfect cube. So we have to actually group into groups of 3. So here's my first grouping of 3 of the same type of numbers. And then here is my second grouping of 3. So we can figure this out pretty quickly because we simply take one number from each group. So here I'm going to say this represents 2, and then times 3. So the cube root of 216, 2 times 3 gives me 6, is 6. And we can check that because 6 cubed equals, let's check what that is in my calculator. 6 to the power of 3 gives me 216. So that is correct. I've essentially verified my solution there. Okay. So that is how you can do these two questions. So again, that was a little bit of review. It's important to understand because moving forward, we're going to have to deal with where this doesn't perfectly happen. Okay. Okay, so let's maybe do a few more examples. So estimating non-perfect cubes and roots. So using perfect cubes and roots to estimate non-perfect square roots and cube roots. So here it says, place the following radicands on a number line. Okay, so we have to estimate these things. How the heck are we going to estimate these things? Well, we have to know what the perfect cube or the perfect square is in order to determine this. So let's look at square root 20, for example. That definitely isn't a perfect square, okay? But what I do know is what's the next perfect square next to this? So let's maybe list a few to begin with. So 1 squared equals 1, 2 squared equals 4, 3 squared equals 9, 4 squared equals 16, 5 squared equals 20. And you can also rewrite this as 1 equals square root 1, 2 equals square root 4, 3 equals square root 9, 4 equals square root 16, 5 equals square root 20. Okay, so if we look at 20, root 20, it falls between, or sorry, this should be 25. That's some bad math on my part. Okay, so this should be root 25. So square root 20 here falls between the perfect square root of 25 and the perfect square of 16. So here, this falls between root 25 and root 16. Okay, now recognize that this equals 16, root 16 equals 4. So this roughly equals 4. Root 25 equals 5. So that means, and I can kind of estimate this, root 20 is closer to 16 than 25 is to 20. So this is going to be roughly, and this is a really rough estimate, probably like 4.4. Okay, it's almost in the middle, but not quite. Okay, so I'm going to estimate this to be 4.4. And again, can I use my calculator? I sure can. I could possibly check what this is. Okay, so the square root of 20 is roughly 4.4. Look at that. So why don't I just use my calculator? Because guess what? Unfortunately, you might not be able to use your calculator on a section of the exam. Okay, so you actually have to know how to do some of this by hand. Okay, now this is listed some of our square roots. So we could actually estimate square root 40 too. We're going to have to go up a little bit because right now we're only at square root 25. So let's go up a little bit more. So 6 squared equals 36. So that means 6 equals the root of 36. Okay. 7 squared equals 49. So that means 7 equals the square root of 49. So now we can estimate root 40 pretty easily. So the square root of 40, let's find what that falls in between. So square root 40 falls in between the perfect squares of 36 and 49. So root 36 and root 49. This equals, root 6 equals 6. Root 49 equals 7. 40 is closer to 36 than 40, so I'm going to estimate this to be roughly 6.3. Okay, so now we have kind of listed a few of our numbers. So let's maybe make root 20 right here. So I'm going to put my roots on the top and then the actual estimate on the bottom. So 4.4. So root 40 is going to be a little bit bigger than that. Root 40 will be here at 6.3. Okay, so let's keep going here. So we've got root 40 down, we got root 20 down. Let's do root 27. So running out of room here, let's maybe put it here. So root 27, so what does root 27 fall in between? Well, root 27 falls in between root 25 and root 36. So root 25 and root 36. Remember, root 36 equals 6. Root 25 equals 5. Okay, so here, root 27, well, that's way closer to 25 than it is to 36. So I'm going to estimate this to be about 5 point, maybe let's make it even 1.5. Okay, because Again, you can make it 5.2. It's a rough estimate, but it is definitely going to be closer to 5 than it is to 6. So that means we can actually place this down. Root 27 is roughly 5.15. Okay, and there is one of our guesses or estimates. Okay, let's see how close I am just to kind of make sure we're going okay. So the square root of 27, look at that, it's 1.9 and we guessed 1.5 or 0.15. So that's pretty darn close. Okay, so now let's move on to, now we're cube rooting. So we cannot use this anymore because this is all about squaring. We need to do a few cubes. So here, 1 cubed equals 1, 2 cubed equals 8, because remember, 2 cubed equals 2 times 2 times 2. 2 times 2 is 4 times 2 is 8, okay? 3 cubed, well, 3 times 3 is 9, times 3 is 27. 4 cubed, I might have to do some math there. So 4 times 4 times 4. What is 4 times 4? Well, that's 16, and then we still have a 4 here. 16 times 4 gives me 64. Okay, so let's kind of stop there and see if we can use all of that. So remember, we can write this out in terms of cubes. So 1 equals the cube root of 1. 2 equals the cube root of 8. 3 equals the cube root of 27. And 4 equals the cube root of 64. Okay, so let's focus on cube root 10. So let's make sure we write our 3 in the index there. Now let's look at what we have here. Well, cube 10 is going to fall between cube 8 and cube 27. So this will be cube 8 and cube 27. Cube 8 is equal to 2. Cube 27 is equal to 3. Now look at how much closer 10 is to 8 than 27 is to 10. So this is literally going to be roughly, I'm going to say 2.1. So very, very close to 2. So if I want to put this on my number line, 2.1, so that's roughly where cube 10 is. Okay. Now let's look at cube 40. So again, what numbers does this fall between? Well, this falls between cube 27 and cube 64. Okay, so cube 27 is 3. Cube 64 is 4. Now 40 is kind of in the middle almost. So to get to 27 to 40, you're adding 13. To get to 40 to 64, you're adding 14. So I'm going to roughly estimate this to 3.4. Okay, so this will still be below here. So that's kind of interesting to look at. The cube of 40 is actually roughly 3.4. Okay, so that can be kind of the confusing part. You see bigger numbers and you automatically think this would be bigger, but it's being cubed, so it's actually making it a much smaller number. Okay. And then lastly, we want to do the fourth root of 100. Okay, so let's maybe talk about some of the fourth roots. So 1 to the power of 4 equals 1. Any number to the power, or 1 to the power of any number is just a 1. 2 to the power of 4, let's see what that equals. So we're going to have to do some math here. 2 times 2 times 2 times 2. So 2 times 2 gives me 4. And I can also make this 4. 2 times 2 is also 4. 4 times 4, well, that's 16. So I have 16 here. Then we got to do 3 to the power of 4. So let's do 3 to the power of 4. So 3 times 3 times 3 times 3. So here I get 3 times 3, which is 9. And then I have 3 times 3 again. 3 times 3, so that's also 9. And then 9 times 9 is 81. So this is going to equal 81. So it's getting big very, very fast. 4 to the power of 4. I might need to cheat and use my calculator here, and that's okay. The big thing is showing that you kind of, and again, on an exam, you wouldn't be asked to do like a 4 to the power of 4. But let's see if we can figure it out. So 4 to the power of 4, 4 times 4 is 16 times 16. So 16 times 16, that equals 256. Okay, and now we can represent this in cubes. So fourth roots. So 1 equals the fourth root of 1, 2 equals the fourth root of 16, 3 equals the fourth root of 81, and 4 equals the fourth root of 256. Now, if we look at our fourth root of 100, let's estimate where that is. So the fourth root of 100, well, what does fourth root of 100 fall between? That falls between the fourth root of 81 and the fourth root of 256. So this will be the fourth root of 81 and the fourth root of 256. Okay, now the fourth root of 81 equals 3. And the fourth root of 256, that equals 4. Now, 100 is much closer to 81 than it is to 256. Way closer, in fact, that I'm going to make this roughly 3.05. Okay, could be 3.1. Okay, so let's go over here. And would you look at that? That falls pretty nicely. Even if I made it 3.1, it would still fall in between here. Okay. So this will be 3.05, which is, I'm guessing, is the fourth root of 100. Okay. And there is my number line. So if I were to list these in ascending order, it would be 3 root 10, fourth root 100, cube root 40, square root 20, root 27, root 40. And there would be from lowest to greatest. Okay, so that definitely takes a lot of skill and practice. So make sure you try a few out on your own and come ask questions if you're a little confused. Let's do one more, and let's estimate the values of the following radicands. Okay, so it's really the same thing we just did, except we're just focusing one at a time. Now remember, odd indexes can have negative radicands, right? Odd indexes can have negative radicands. So here, this is actually possible. What am I doing here? Well, let's talk about let's go -1 cubed. -1 cubed is simply -1. -2 cubed, well, that's going to give me -8, okay? And we can kind of see up here that the negative just stays along with it if you have an exponent that's an odd number. So 2 cubed is 8, -2 cubed is -8. So -3 cubed is going to be -27. So -3 cubed equals -27. So that means I can also write this in terms of cubes. So -1 is going to be the cube root of -1. -2 is going to be the cube root of -8. -3 is going to be the cube root of -27. So here, what does cube of -25 fall in between? Well, it falls in between -8 and -27. So the cube of -8 and the cube root, of -27. And now let's look at this. Cube root of -8 gives me -2. Cube root of -27 equals -3. Now, -25 is much closer to -27 than it is to -8. So I'm going to estimate this to be roughly -2 let's say 85. okay? So I'm going to estimate this to equal negative 2.85. And again, I usually give or take 1 decimal place. So let's maybe pull out a calculator and see what it actually is, see how close I got. So I'm going to press math, and then I'm going to press 4 here, negative 25. And would you look at that? I was pretty darn close. Negative 2.92, negative 2.85. So realistically, I would give this a correct answer because you're really only 7.07 decimals off, which is pretty darn good. Okay, so there's my estimate there. And again, if it ever tells you to estimate without a calculator and say you have a calculator around, you pretty much just want to show this method here, okay? Even if you maybe are using your calculators to find these, you want to show that you know how to estimate properly. Okay, let's maybe do this one. So the square root of 45. So here we need to list our squares, which we actually already have up here, right? So you do the same thing here. Now, root 45 is going to fall in between root 36 and root 39. So this will fall between root 36 and root 49. So that's the nice part. On your exam or on a worksheet, if you just have the first few squares and the first few cubes listed out, you can do these pretty quick. Because now I know that the root of 36 is 6. I also know that the root of 49 is 7. Look how much closer 45 is to 49 than to 36. So I'm going to estimate that to be roughly 6.7. Okay, it's kind of close to half, but not quite. So the root 45, I'm going to estimate to be 6.7. Okay, let's see how accurate I was again. So, second square root, 45. Wow, look at that. I was right on the dot. So that was pretty darn good. So 6.7 is right there. Okay, and my last one, I want to fourth root negative 400. Now this one might look scary, but indeed, what is happening? My index is even. What happens if an index is even? Well, that goes to my front page. If I have an even index, your Radican cannot be negative, okay? So if I plug this into my calculator, you're gonna get a big fat error. So this is pretty easy to estimate because this does not exist, okay? Now there is no AFL at the moment. If there is now, please go try it out. But I would suggest going to 4.1 and definitely trying out a few questions in the textbook. If I've given you a worksheet, please go through that. But at the moment, I just worked through a textbook if you have that available. Other than that, if you have any questions, be sure to come ask, as this first portion is definitely, it might feel kind of maybe easy, but it's definitely important to go through. Thanks.